Hello students, we are solving the IB Math AAHL past paper questions and currently we are solving the IB Math AAHL May 2022 paper 2 time zone 1 past paper. And today we will be solving the question number 7 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel NS Online Math Tutoring classes. So, without any further delay, let us start answering question number 7. The maximum mark is 9. Actually, there are three subparts to this question. I have brought in the first two subparts. I'll be bringing in the subpart C later on. Okay. So, consider the vectors A and B such that the vector A is, this is the column vector 12 and negative 5, and the modulus of the vector B, that is the magnitude of vector B, is equal to 15. Subpart E says find the possible range of values for A plus B, the addition of these two vectors, and the modulus of this. That means the magnitude, okay, of the resultant vector. So, how can these two be um, located in the, we are taking the two-dimensional plane because A is having two dimensions, so we will be taking the plane, of course. And how can they be located? The A and B vectors. Maybe, say, this is the vector A. I do not know what is the magnitude. I have to calculate, in fact. But I am assuming that this is the vector A. Okay. And okay, let us find the modulus, the magnitude of vector A. The magnitude of vector A will be equal to 12 square plus negative 5 whole square, which is equal to 144 plus 25, that is 169, and square root of 169 will be equal to 13. Okay. So the magnitude of the vector A is 13 and the magnitude of the vector B is 15. Now the vector B can also be in the same direction as the vector A. It can be in the opposite direction or it can be at an angle to the vector A. First of all, let me take that the vector B is in the opposite direction. Let us start with this case. Okay. So taking another color, maybe this one. And since the modulus, the magnitude of vector A, the B vector is starting from the end point of the A vector. That is what we do when we add the two vectors and we try to get the resultant of the two vectors. We first of all draw a vector, and from the point where the first vector is at ending, we start the drawing of the second vector. So this is the point where the vector A is ending, and from here I am drawing the vector B, and it is in the opposite direction. Okay. So this is vector B, and this was the end point of vector A. Oh, sorry, the starting point of vector A. Okay. And since the magnitude of vector A is 13 and the magnitude of vector B is 15, so uh, the B vector has moved through a greater distance. And what is the resultant vector? The resultant vector will always be, we add the starting point of the first vector to the ending point of the second vector. And this will be the direction. This is the normal thing that we do. And in this case, we don't have to think about what is the direction, what can be the direction, because we know that vector b's modulus is or magnitude is more than vector a's magnitude. So obviously the resultant vector will be in the direction of vector b. Okay? Let us name the resultant vector as say r. Okay, and what will be the magnitude of r? It will be obviously 15 minus 13. In this case will be equal to 15 minus 13, that is equal to 2. Okay, so this is the first case. What can be the second case? Let us see. The second case, maybe this is the vector A. This is the vector A. Starting point of vector A is this. And now we have to draw the vector B. Now this is the ending point of vector A. From here, I'll be drawing the vector B. Now I am supposing that vector B is at an angle with vector A. The angle is not equal to 0 or 180 degree. So maybe this is the vector B. This is the vector B. So what will be the resultant? The resultant will be this vector. Actually, I'm not taking the straight lines. So these vectors that I am drawing, definitely not perfectly straight lines, but you understand. Okay. So this is how we get the resultant. We draw the vector from the starting point of the first vector. We connect this point to the ending point of the second vector. So this is the vector r. And by just looking at this vector, this is r and this is r, you can very well understand this vector r will be having a magnitude more than definitely. This is such a little one and this one is so big. Okay. And what is the third case? With that, maybe the third case is this. Third case I am taking that the two vectors are in the same direction. So this is E. This is the starting point. This is the ending point. And this one is B. Okay. So now what will be the resultant vector? It will be obviously in the same direction. Excuse me, I'm having a bad voice. I'm having throat problem. So sorry. So the resultant vector should be in the same direction as these two vectors A and B, and it will be starting from the starting point of the first vector, and it will be ending at the ending point of the second vector. So again you can see that the magnitude of this vector should be more than this one. Okay. So, and what is the magnitude of this? The magnitude in this case, both are in the same direction, so they will get added. So this one is 13 and this one is 15. This is not, in fact, okay, it has gone. Thank you. So this is equal to, let me write over here because I have taken on the right hand side. This should be equal to 13 plus 15 is 28. So we are seeing that this is the intermediate condition, and uh, as the angle, this angle increases, the magnitude of this vector goes on increasing, and this is the extreme case when this was when the angle between these two vectors was 0 and this is 180-degree. So now you can very well see that starting from the magnitude of 2, it has come to the magnitude of 28. Okay. So we are asked to give the possible range of values. So these will be the extreme points. Therefore, you have to, in fact, this is the starting of the answering question, the Sapat A, and I am writing the final answer over here. Therefore, 2 is less than or equal to A plus B is less than or equal to 28. This is the answer. Okay. Now we come to the subpart B. Consider the vector P such that P equal to A plus B. That means the magnitude of P is equal to the magnitude of A plus B, and the direction of the vector P is the same as the direction of A plus B vector. That is the resultant vector. And the subpart B says, given that the magnitude of A plus B vector is a minimum, find P. So the magnitude of A plus B vector is a minimum. That means the magnitude of A plus B is 2. Therefore, the magnitude of P should also be equal to 2. Let me write these. Okay. Since P is equal to A plus B, therefore, P modulus or magnitude of the vector P is equal to the magnitude of the vector A plus B, and they have the same direction. Direction of P is the same as the direction of A plus B. Okay. And when A plus B magnitude is minimum, okay, also since magnitude of A plus B is equal to 2, minimum means it should be equal to 2. Therefore, magnitude of P is also equal to 2. Okay. And what is the direction of the vector A plus B? When the magnitude of this vector is equal to 2, this is this case. Okay. In this case, we are seeing that the resultant vector, in this case, the name of the resultant vector, it is not the resultant vector in fact, but this P should be having the direction of the resultant vector, and the direction of the resultant vector is in the direction of the vector P. But we do not know what is the direction of vector P because they have not given us the vector B. They have given the magnitude of the vector B. But what we know is the vector B is in the opposite direction of vector A. Okay. So, how do we find the direction of a vector? We just get the unit vector in the direction of the given vector. That is what we take. Okay. If we want to get some vector in a particular direction, we get the unit vector along that direction, and then we, whatever magnitude is needed, we multiply with that magnitude. That is what we do. So, if we get the direction vector of A, the unit vector rather of along the direction of A, and if we just change the sign, it becomes it becomes a vector which is directing towards the opposite side as the direction of the vector A, sorry. That means it will be along the vector B's direction. Okay, let me just show what I am doing. Okay. Over here, I am getting in fact, I have got the magnitude of vector A. So, unit vector along vector A in the direction of vector A is equal to 1 over 13, 12 and negative 5. Therefore, unit vector in the direction of B is I'm just changing the signs. 1 over 13 and minus 12 and 5. Let me see if I can. Yeah, I think this is better. Now you can see 1 over 13, negative 12 and 5. Okay. So therefore, and the magnitude of the vector P is 2. We have found the direction of the vector P. We have to get the magnitude of this vector P as 2. So, since we have got the direction of the vector P, we can multiply with its magnitude to get 2 over 13. I'm just multiplying. This is the unit vector in the direction of the resultant vector, which is in the direction of the vector B. So the P will be in the direction of the vector B. And the unit vector, how did we get this unit vector? First of all, we have got the unit vector in the direction of vector A. Since B is just opposite in direction to vector A, therefore, I have just changed the 12 to minus 12 and minus 5 to 5. Obviously, if we take one direction as positive, the other direction will be negative. Okay. So, this is the unit vector in the direction of vector B. So, in order to have the magnitude of 2, I am just multiplying this unit vector with. So, this is 2 over 13 minus 12 and 5. Okay. So, this was the answer for the subpart A. And this is the answer for the subpart B. Okay. Consider the vector q such that q equal to this column vector x and y, where x and y belong to the set of positive real numbers. They are positive numbers. And subpart C, the question for subpart C is find q such that the modulus of q, that is the magnitude of q, vector q is equal to the magnitude of the vector b, and q is perpendicular to a. And this is the vector A, and the magnitude of vector B is given to be equal to 50. Okay. So since the magnitude of Q is equal to the magnitude of the vector B, therefore the, sorry, don't know whether it will be getting erased. It did not. Okay. Is equal to 15. Now it has. Okay. So and they are saying q is perpendicular to A. That means the dot product of the vector q with vector A will be equal to 0. And this is the column vector for the vector q. So q dot A should be equal to xy dot 12 and minus 5 equal to 12x minus 5y, and this should be equal to 0. Okay, we are having two variables, we should be having two equations as well. So what is the another equation? The second equation, or you can call this as the first equation, will be what is the modulus, what is the magnitude of q? It will be square root of x square plus y square. This should be equal to 15. Okay, or we can say if we square both the sides, we can see x square plus y square is equal to 10 square is 225. Okay, and fine, this is equation number 1. Let us number this equation as 1 and this is this as 2. So from here we are getting 5y is equal to 12x, and so y is equal to 12 over 5x. Okay, and we will be substituting this value of y in this equation. So therefore x square plus 12 square over 5 square, 12 square is 144, 5 square is 25, x square should be equal to 225. Okay, and let us make the denominator as 25 for both the terms on the left hand side. So this will be 25x square plus 144 x square equal to 225. Okay, and 25 x square, I'm just multiplying the entire equation by 25. So it is 25 x square plus 145, or rather I can write, don't know whether it will be going. Okay, so I'm just adding 25 with 144, so it is 169 x square equal to 225 times 25. Okay, or therefore x square is equal to 225 times 25 over 169. And this is paper 2, so you can use a calculator. I'm not using it because I can see the squares. 15 square times 5 square over 13 square. Therefore, x, I'm taking the square root, and x and y are positive numbers, so positive real numbers. So x will be equal to 15 times 5 over 13, which is equal to 75 over 13. So now coming to y, therefore y is equal to 12 over 5 times 75 over 13. Okay. 5 times 15 is 75, and you can use a calculator, but well, 12 times 5 is 60, carried 6. 12 times 1 is 12, plus 6 is 180, 18. So it is 180 over 13. Okay. So we can say, therefore, the vector q is equal to 75 over 13 and 180 over 13. Okay. Fine. So this completes our question number 7, and I'm Nilanjana Sanyal. I'm an online IB Math A, SL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring sessions to all my students. And as you are seeing currently, I am solving the past papers, the IB Math AHL past paper questions, and I am uploading them in my YouTube channel. So, in case you are liking my explanations, if you have come to this end, I hope that you have liked my explanation. Then please to give this video a like, and please to share this video with your friends so that even they can get benefited by watching this video. And please to subscribe to my YouTube channel. It will be motivating me to make more math videos for you. And if you subscribe, the number of subscriptions will be more, and the YouTube will also be understanding that people are liking my channel, so YouTube will be showing my videos to more number of people. Okay. So thank you for staying with me till the end. And we meet again very soon. In our next session, we will be solving question number 8 of the same paper. So till then, bye.